Okay, let's go.
Welcome back to the deep dive. Today we are opening up a file that I think a lot of people just assume is totally closed. We are looking at antidepressants.
Yeah, which is a massive category.
It really is. I mean, we're talking billions of dollars, millions of users globally. And I think you'd naturally assume that for something so ubiquitous, the science would be settled, like totally clean and completely understood.
Right, and if you assume that, you would be very wrong. It's a huge topic. It covers major depressive disorder, anxiety, OCD, even some neurodegenerative diseases.
Yeah.
But you're right to point out that uncertainty at the start,
Yeah.
because at the heart of this multi-billion-dollar industry, there is still this very large, very dark room that we're all just kind of feeling around in.
And that is exactly what jumped out at me immediately in the research. We have this popular narrative that scientists, sat down, mapped the brain, found the exact sadness button, and built a pill to just turn it off.
Which couldn't be further from the truth.
Exactly. The history is actually incredibly messy. In fact, the entire modern era of psychopharmacology started completely by accident.
The happy accident. That's what it's often called in medical history. It really challenges that whole idea of the brilliant light bulb moment in science. Sometimes you're looking for one thing and you literally just trip over something much more important.
So let's set the scene for that, because this origin story is fascinating. We aren't in some sleek modern lab. We are in the early 1950s in a tuberculosis ward.
Right. And the context of the 1950s is key here. If you had severe depression back then, your options were pretty terrifying.
To say the least.
You had crude psychoanalysis, which took years. You had lobotomies, which physically destroyed personality. Or you had electroconvulsive therapy, which was effective, yes, but very brutal in its early forms. There was simply no pill.
Until they started treating these TB patients with a new drug called aproniazid.
Exactly. So aproniazid was designed specifically to attack the tuberculosis bacteria in the lungs. But the nurses and doctors on the ward started noticing this really strange pattern.
The patients were getting happier.
Much happier. They weren't just coughing less. They were suddenly energetic. They were socializing in the halls. They had this renewed vigor.
Yeah.
For a ward full of terminally ill people, the mood was inexplicably high.
And that's when the penny dropped for the researchers. They realized the drug was doing something secondary to the brain.
Yes, they eventually identified it as a monoamine oxidase inhibitor, or MAOI. It was basically blocking the enzyme that breaks down neurotransmitters in the brain. Suddenly, the medical community realized that mood wasn't just this spiritual state or a character flaw, it was chemical.
And if it was chemical, it could be manipulated.
Precisely.
And it wasn't just aproniazid, right? The sources also talk about this Swiss psychiatrist, Roland Kuhn. He had a very similar kind of oops moment around the exact same time with a different drug called imiprimine.
Yes, Kuhn. Now, he was actually trying to treat schizophrenia. He thought imipramine would act like a sedative or a mild antipsychotic.
But it didn't.
It failed miserably at that. The schizophrenic patients just got more agitated. But instead of throwing it away, he decided to try it on his depressed patients. And it worked wonders. That discovery gave us the tricyclic antidepressants.
So by the late 50s, we basically have two major classes of drugs, the MAOIs and the tricyclics. But reading about these early drugs, they sound really rough. The literature keeps referring to them as dirty drugs. And just to clarify for everyone listening, that's not about hygiene. That's a term about pharmacological precision, right?
Exactly. In pharmacology, a clean drug hits only the exact target you want. It's like a laser pointer. A dirty drug is more like a shotgun.
Right. It hits the target, but also everything else in the room.
Exactly. These early drugs definitely boosted mood, but they also severely messed with blood pressure. They caused extreme dry mouth, dizziness, and in the case of the MAOIs, they created potentially lethal interactions with certain foods.
This is the famous cheese effect.
The cheese effect, yes. You couldn't eat aged cheese, you couldn't drink red wine, or you could literally go into a hypertensive crisis and die. It was a very high-stakes treatment.
Which perfectly sets the stage for the late 1980s, the arrival of the SSRI. Things like Prozac, Zoloft, Paxil. Now, the narrative I grew up with was that these drugs took over the world because they were just vastly better at curing depression than the old stuff. But looking at the data we have here, that's actually a myth, isn't it?
It is a massive misconception. If you look at the raw efficacy data, meaning how well they actually reduce depressive symptoms, Prozac is not statistically better than that old imipramine from the 1950s. The SSRI revolution wasn't about power. It was about safety.
It was about not accidentally killing the patient if they ate a slice of sharp cheddar.
Basically, yes. SSRIs are much cleaner. They target serotonin specifically. You can't easily overdose on them, and they don't have those terrifying dietary restrictions. That safety profile is what allowed them to move out of the specialized psychiatrist's office and straight into the primary care clinic.
Which, as the sources point out, brings its own set of problems. They argue that this ease of use led to massive overdiagnosis. Because when a general practitioner has maybe 15 minutes to solve your problem, a safe pill is a much easier answer than referring you out for deep, ongoing therapy.
It lowered the barrier to entry, for better and for worse.
But let's get into the mechanics of this, because this is the part that I think drives logically minded people a little crazy. We've been using these things for decades, but we still don't really know how they work.
We have theories, strong theories. But yes, the actual mechanism is still a bit of a black box.
Most people are familiar with the chemical imbalance theory, the monoamine hypothesis. The idea is you're low on serotonin, the pill fills up your serotonin tank, and you feel happy. It's simple. But the notes say this theory is effectively dead today.
It's considered far too reductionistic by modern standards. And there's a very clear smoking gun that effectively killed that specific theory. It's timing.
Tell me more about that.
Well, when you swallow an SSRI, your brain's serotonin levels spike within hours. So if depression was purely just a lack of serotonin, you should feel completely cured by that same afternoon.
But you don't.
You don't. It takes 4, 6, sometimes up to 8 weeks to actually feel a clinical difference in your mood. That lag time proves it's not just about refilling a chemical tank.
So what is actually happening during those 6 to 8 writs? The sources heavily feature something called BDNF. This seems to be the leading modern theory.
Yes, this is the neuroplasticity argument. You have to think of serotonin not as the mood molecule itself, but as a trigger. Increasing serotonin signals the brain to release a specific protein called brain-derived neurotrophic factor, or BDNF.
I've heard BDNF described as miracle grow for the brain.
That's actually the perfect analogy. Severe depression causes neurons in the hippocampus, which is the part of the brain heavily involved in memory and emotion. It causes them to physically wither and shrink. BDNF acts like a fertilizer. It helps those damaged neurons regrow and form new, healthy connections. But just like growing a plant in your garden, that physical reconstruction takes time. That's why you have the 6-week lag. You aren't waiting for a chemical to build up. You're waiting for the brain to physically heal its own structure.
That makes so much more sense than the fuel tank idea. But it's still highly theoretical. I think it feels a little unsettling to a lot of people that we are altering our brain chemistry without a 100% confirmed roadmap.
It can be unsettling.
Yeah.
But let me give you a parallel from the medical world that usually calms people down. Think about general anesthesia. We have been using ether and other gases to put people to sleep for surgeries for over 160 years. It is the absolute foundation of modern surgery.
Right.
But if you corner a top anesthesiologist and ask them for the definitive, proven molecular mechanism of exactly how that gas makes you unconscious, they can't give you one, really. We have theories about membrane expansion and protein binding, but no unified proven law. We don't fully understand it, but we know it works, and we know we desperately need it. Psychiatry is in the exact same boat with antidepressants.
Okay, that is a very fair comparison. We accept the utility even if the how is a little fuzzy. So let's move to the practical side of things, the menu. Because there isn't just one single antidepressant out there. There are dozens. And the biggest study ever done on this, the STARD trial, had a pretty shocking conclusion regarding which one is the best.
The STARD trial was a massive landmark moment in the field. And the headline from that trial was, essentially it's a tie. No single class of antidepressant, whether it's an SSRI, an SNRI, an NDRI, none of them were statistically more effective than another at reducing symptoms across the board.
So Zoloft isn't inherently stronger than Prozac. They're all just playing in the exact same league?
Correct. Efficacy is roughly equal across the board.
Which raises the most obvious question. If they all work about the same, how on earth does a doctor choose which one to prescribe to you?
That right there is the art of psychopharmacology. Since the efficacy is equal, you don't choose based on what will work best to cure the sadness. You choose based on the side effects. You are basically trying to match the drug's baggage to the patient's lifestyle.
Let's play this out with some patient avatars based on the notes, because I think this really clarifies how doctors actually do this. Let's say patient A is the insomniac. He's deeply depressed, but he's also highly anxious. He's lost 20 pounds because he has zero appetite, and he hasn't slept through the night in months.
Okay, so if you give that guy Prozac, which can be very stimulating, you might actually make his insomnia and anxiety worse.
Right.
So instead, you look at mirtazapine. Mirtazapine is a strong antidepressant, but its specific side effects happen to be heavy sedation and increased appetite. For the insomniac, those aren't bugs. They're features. You treat the depression and you fix the sleep and appetite issues with one single stone.
Okay, let's flip it. Patient B is the lethargic. She can't get out of bed. She has zero energy. She's sleeping 14 hours a day. And crucially, she is terrified that taking medication will kill her sex drive.
And mirtazapine, or really any SSRI, would be a terrible choice because sexual dysfunction is a major hallmark of those serotonin drugs. For her, you'd likely reach for bupropion, better known as Wellbutrin.
Because it doesn't use serotonin.
Exactly. It works on dopamine and norepinephrine. It's activating, so it gives you energy, and it generally has absolutely no negative effect on libido.
But there's a catch with Wellbutrin, right?
A big catch. Because it's so stimulating, almost like drinking a lot of coffee, if that patient also suffers from high anxiety or panic attacks, Wellbutrin can send their anxiety right through the roof.
It's all about balancing those trade-offs. Okay, patient C, this is the forgetful patient. Maybe they are a busy college student or just someone who is bad at keeping routines. They are probably going to miss a pill here and there.
For them, you want fluoxetine. That's Prozac. It has an incredibly long half-life. It stays active in your system for days. So if you forget your dose on Tuesday, you're still medically covered on Wednesday. It's very forgiving.
Contrast that with patient D, who gets put on paroxetine, which is Paxil. The notes were very clear about Paxil.
Paroxetine is the exact opposite of Prozac. Very short half-life. If you miss a dose, you feel it fast. And getting off Paxil is notoriously difficult because the withdrawal, what we call discontinuation syndrome, hits incredibly hard.
Brain zaps, right?
Brain zaps, severe dizziness, flu-like symptoms. Paroxetine is effective, but it's sticky. It is not generally a first-line choice anymore for that reason.
What about the giants? The ones everyone knows. Escitalopram and sertraline.
Escitalopram or Lexapro is great if a patient has a lot of other medical issues because it doesn't interact much with other drugs. But it has a dose ceiling. You can't prescribe high doses because it carries a risk of disrupting heart rhythms, specifically QTc prolongation.
And sertraline. Zoloft.
Great for treating comorbid anxiety or PTSD alongside depression, but it has a much higher risk of gastrointestinal issues. So the golden rule with sertraline is you always take it with food.
The quote in the research that completely summed this up for me was, "The best antidepressant is the one that the patient actually uses."
That really is the bottom line. The most perfect biochemical match in the world is totally useless if the side effects make the patient feel so awful that they just flush the pills down the toilet.
Speaking of feeling awful, we need to talk about the investment strategy of these drugs, because the timeline we ask patients to accept is just cruel.
It is. We are asking patients in severe distress to take a massive leap of faith. The side effects, the nausea, the jitteriness, the headaches, those show up immediately in the first week.
But the benefits don't.
Right. The benefits don't show up for 6 to 12 weeks. You literally have to feel worse before you get to feel better. It is an investment in your future self.
And some of these side effects that pop up are just bizarre biological quirks. Let's talk about Prozac eyes.
It sounds like an urban legend, doesn't it? But it's very real. SSRIs suppress REM sleep. But the brain has this built-in pressure to perform rapid eye movements. So sometimes patients will have rapid eye movements while they are entirely in non-REM sleep.
So if you watch them sleeping, their eyes would be darting all over the place, but they aren't even dreaming.
Exactly. It's completely harmless, but it shows you just how deeply these drugs impact our fundamental brain architecture.
And the sweating. The notes were very specific to mention this as a major issue.
The sweating can be profound. It's likely linked to the dysregulation of norepinephrine. Some patients will wake up having completely drenched their bed sheets, especially in the summer. It's actually a major reason people stop taking their meds, but doctors frequently forget to warn them it might happen.
And there is a much more serious issue, hyponatremia.
Yes, this is a critical public service announcement for anyone caring for elderly parents. In older adults, starting an SSRI can cause a dangerous drop in blood sodium levels during the first few weeks.
What does that look like from the outside?
It looks a lot like sudden confusion or extreme lethargy. So if your grandmother starts acting strangely out of nowhere right after starting Zoloft, Get her sodium levels checked immediately.
And we also touched on sleep earlier, but just to be clear, most of these drugs actually worsen your sleep efficiency, right?
Yes, more awakenings, delayed REM sleep. Trazodone and bupropion are the rare exceptions there, but generally SSRIs make sleep a bit more fragmented.
So assuming you navigate all of these side effects, the sweating, the sleep issues, and you finally find the right drug that works, the underlying fear everyone has is this forever? Am I stuck taking this pill for the rest of my life?
The answer is usually no, but it is highly dependent on your personal medical history. The clinical guidelines are fairly algorithmic. If it's your very first depressive episode, we treat for 1 year.
Why a year?
That gives the brain enough time to fully stabilize and grow that lawn back with the BDNF we talked about.
And if I taper off but eventually crash again?
For a second episode, the recommendation extends to 2 years of treatment.
And a third episode.
That's the tipping point. The statistical data shows that after 3 major recurrences, the risk of relapse if you stop the medication approaches 100%. At that point, the doctor and patient need to have a serious conversation about lifetime maintenance.
Hearing the phrase lifetime maintenance is a really heavy concept, and I think it feeds right into the skepticism a lot of people feel. If I have to take this forever, is it actually curing me? Or am I just completely dependent on a placebo? Which brings us to the controversies, because you cannot talk about antidepressants without addressing the placebo debate.
It is the elephant in the room, and the critics aren't wrong. The placebo response in depression trials is massive. It hovers around 30 to 40%.
That is huge. That means a massive chunk of people feel better just because they believe they are taking a cure. So are the drugs actually doing anything biochemical, or is it all just medical theater?
They are definitely doing something biochemical, but the nuance is entirely in the severity of the illness. In cases of mild depression, the active drug often does not beat the sugar pill placebo. But in acute severe depression, the drug creates a very clear statistical separation from the placebo. The biology really matters when the illness is grave.
But the notes brought up a really important counterpoint about the placebo effect that I had never considered. We tend to treat placebo like it's a fake or invalid result, but it's actually incredibly powerful medicine all on its own. The sham surgery studies completely blew my mind.
This is truly one of the wildest things in all of medicine. They've done these controlled studies on knee osteoarthritis. They take a group of patients, put them under anesthesia, make a surgical incision on the knee, do absolutely nothing inside, and sew them right back up.
And the result?
A huge percentage of those patients report significantly less pain. They can walk better. The sheer belief that they had a medical intervention actually caused their brains to release endogenous opioids and physically reduce their inflammation.
Yes, that's incredible.
So yes, antidepressants have a strong placebo component, but so does actual physical surgery. We shouldn't dismiss a psychiatric treatment just because our brains are helping the healing process along. The doctor-patient relationship itself is therapeutic.
That really puts it in a new perspective. But there is a controversy in the files that is much darker than the placebo debate, and that is the link to suicide, the black box warning on the bottle.
This is a clinical paradox that requires very careful, nuanced handling. The FDA requires a strict warning that antidepressants can increase suicidal thinking. But if you look at the data, there is a stark split based entirely on the patient's age.
Let's break that down. Who is actually at risk?
The increased risk is primarily concentrated in people under the age of 24. In children and young adults, that activation, that initial energy boost we talked about with the side effects, it can sometimes kick in weeks before the mood actually improves.
So you have a patient who is previously too lethargic to act on their dark thoughts, and suddenly you give them the physical energy to do so.
Exactly. Or it can manifest as severe, intolerable agitation. That is why young people need extreme monitoring when starting these meds.
But what about for older adults?
The data flips completely. In geriatric populations, SSRI use is associated with a significant decrease in suicide risk. So the exact same drug that requires intense vigilance in a 16-year-old might be the very thing that saves the life of a 70-year-old.
While we're on the topic of risks in young people, we have to talk about Study 329. The outline flags this specifically as a story of pharmaceutical influence. It honestly sounds like a conspiracy theory, but it's documented fact.
It is a dark chapter. This was a major study on the drug Paxil being used in adolescents. The manufacturer originally published this study, claiming the drug was both safe and highly effective for kids. Doctors worldwide prescribed it to millions of children based entirely on that paper.
But the data was cooked.
Years later, independent researchers finally got access to the raw data, the actual clinical black box notes. They found that the original study had purposefully coded actual suicide attempts under the vague term emotional lability.
Wow.
They had effectively hidden the severe side effects. When the independent team reanalyzed the real numbers, it showed the drug was not effective for kids and was distinctly unsafe. It's a very chilling reminder that we always need independent verification of science, not just pharmaceutical marketing brochures.
That is genuinely terrifying. And it underscores exactly why deep dives into the source material like this matter so much. We have to know what we are putting into our bodies. Now, there's one last major risk category we need to touch on: pregnancy. This seems like the ultimate impossible choice for an expectant mother.
It is a profound risk analysis. SSRI use, especially late in the third trimester of pregnancy, carries a distinct risk of causing persistent pulmonary hypertension in the newborn. It's relatively rare, but it is very serious.
So the natural instinct is to just say, stop the medication immediately.
But you have to weigh that physical risk against the very high risk of the mother relapsing into severe depression. Untreated maternal mental illness is also highly toxic to a developing fetus. You have massive cortisol spikes, poor prenatal nutrition, lack of general self-care. The clinical guidelines generally suggest that for the severely ill mothers, treating the depression is the priority, because a healthy baby ultimately requires a healthy mother.
It really seems like with all of these, the suicide risks, the pregnancy dilemmas, the daily side effects, there are simply no free lunches here.
There never are in medicine. Every single intervention is a trade-off.
Before we wrap up today, I want to leave listeners with one final thought from the research that I found really profound. We spend all this time talking about serotonin like it's just this magic happy chemical, but it's incredibly ancient, isn't it?
It is ancient. Serotonin did not evolve in nature for mood regulation. It's in our gut, heavily regulating our digestion. It's in our blood platelets, regulating how we clot. It's deeply involved in our bone density. It is a fundamental biological signaling molecule that has been around for hundreds of millions of years.
So when you swallow an SSRI, you aren't just selectively tweaking your mood, you are turning a dial on a massive, ancient, whole body system.
Exactly. And while we know that the short-term benefits, like pulling someone out of the absolute abyss of severe depression, are undeniably worth it, we are really still learning what the long-term biological trade-offs are. What happens when you run that ancient system hot for decades? We're essentially running a massive biological experiment in real time.
Which brings us right back to where we started. These drugs are tools. They aren't magic wands, they certainly aren't perfect, but for millions of people, they are absolutely necessary.
And they always work best when combined with therapy, lifestyle changes, and a doctor who actually takes the time to listen to you.
Well, on that note, we are going to close the file on this one. Thanks for joining us on this deep dive. Stay curious, stay skeptical, and we'll see you next time.